Welcome to HP Tuner's Ford Gen 1 Coyote Training Part 19. In this training module, we're going to take a look at bad injector data or bad MAF data and how to distinguish what changes we need to make if we have the data represented incorrectly in our file. So we're going to take a look at some logged examples from a stock intake that's been calibrated from Ford, compare it against looking at bad data. I'm going to be demonstrating what it's going to look like to enter some bad data in so you can see the cause and effect by what you're looking for here and trying to determine what changes you need to make things right in our programming. We do not want to carry bad data in throughout the rest of the calibration process. If we have a bad MAF curve or bad injector data, that can trickle its way all the way down into bad torque tables and then therefore going in and skewing up our drive-by-wire throttle control. So there's a lot of things that can be affected by this. Let's jump in so we can check out working with and determining how we have bad data.
Okay, so let's get started. We're going to be taking a look at bad MAF calibration and or bad injector data and the effect it's going to have on our fuel and airflow modeling within our Ford PCMs. Now this tutorial is going to be illustrating what we need to look for to spot bad MAF curves and or bad injector data. So this is going to be vital because a lot of what you're going to find in your calibration process, it's very easy to bake bad data into either the MAF curve from the injector data being incorrect or just starting off with an incorrect MAF curve and going about the MAF calibration process incorrectly and then having a result of having a bad airflow model. We need to make sure that the airflow model is 100% dialed in, the best of our abilities. We do not want to introduce any errors into the airflow modeling that can be a result of either bad calibration techniques, a bad MAF curve to start off with, or bad injector data, because all of this will affect the fuel and airflow model. So we're going to break down how this is going to work. We've talked about the MAF calibration process in the last tutorial, using our histogram to be able to populate our fuel trim data and then using that to overlay back into the MAF curve to update things. Now, what's going to happen after we do that? How do we validate if our changes that we're making are accurate or not? And or if they're not, what do we need to look for to spot inaccurate changes? Okay, so the first thing I want to do here, I have my 2013 Mustang GT file. This is a JLT intake. This is that file that we saved in the last tutorial. We started off by going in that last tutorial, changing out the stock airbox to a JLT intake, going in and starting off with the JLT MAF curve, which is a solid curve right from our Excel spreadsheet, and then going through and learning how to calibrate everything and get everything dialed in. Now, we had a good MAF curve to start off with, so we know that we really didn't have much of any changes to make to that MAF curve, but we always want to validate everything to make sure it is 100%. Let's jump in and take a look at that real quick. So we're going to go up here to Engine, and then here into our Airflow, into General, and then under MAF calibration, we have our, if we look in here, our mass airflow versus period table. This is what we use to determine what the air mass is coming into the engine. Now this table here is based on our period in microseconds. That's going to be our digital signal from our MAF sensor as the airflow is going across it. And then we'll find it's going to correlate to a certain grams per second worth of airflow. Now you can work in your airflow units here of whatever you'd like, grams per second, pound per hour, pound per minute. I like to work in grams per second because I think it makes the most sense. Again, feel free to change your unit scale to whatever you'd like. Now, this MAF curve that we're left with here is a result of running through that histogram and updating some things within that histogram, taking that copy feature and using the pace special 0.5% type of multiplication function and being able to apply those changes to our MAF curve. Now, the first thing we want to do after we've completed that process is always double check what our MAF curve looks like to make sure it has a nice smooth shape. We can see here that the shape is smooth. We don't have any peaks and valleys in the MAF curve. That indicates that we have some kind of modeling problem. Typically what you're going to find is that you either don't have your cells hit require in your VCM scanner. Let's jump in here real quick. Your cells hit require in your filtering here for your mass airflow tuning histogram. Looking in here, your cells hit require may be too low. You may need to increase them to go filter out bad data. So it might be populating if you're driving through your MAF curve and it's skipping around and not catching a certain point, or it catches a point sweeping through a cell that just seems to be an outlining fuel trim. So it might just catch it at the wrong time and it's showing that maybe one spot's off by 10% while everything else looks pretty good. Well, if you've copied and pasted that data into your back in here, if you copy and paste it, use that paste special back into your MAF curve, you're going to find that that's going to show up in your MAF curve. You might find a hump or a dip in the MAF curve. It shouldn't look like that. That's the very first, very most basic thing. We want to check the shape of our MAF curve. It should be smooth, which it is, so we know at least that functionality has been carried through correctly. Now the next thing, even if we go in and copy and paste that paste special function and multiply and get everything dialed in and our fuel trims look good, that doesn't mean that what we're correlating into our MAF table is accurate. We could be over or underestimating our airflow. And that is going to be a critical, fundamental thing that we need to understand here. Just because we dialed it in using our fuel trims doesn't make it accurate. And if it isn't accurate, if our airflow being reported back into our Ford PCM isn't accurate, everything is thrown off. Variable cam tracking, spark timing tracking, even our torque modeling, all things are going to be off, even our idle control. So we can introduce an error into our modeling that Ford has figured out.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.